A ro-ro planned to move from a berth to a link span in its regular port. 20 minutes before departure, the third engineer started both engines to warm them through. He started the starboard generator so that both generators were running in parallel. The second engineer took over the watch. After handing over, the third engineer left the second on his own. 5 minutes later, the master rang standby on the telegraph. The second connected the port shaft generator to the switchboard to supply power for the bow thruster. The master started the bow thruster and ordered the lines to be let go. The second went into the engine room to start one of the seawater service pumps. On his return to the engine control room, he found the port generator high-temperature freshwater alarm sounding. He cancelled the alarm and went to investigate. Unable to find the cause of the overheating, he returned to the control room. By then, many more alarms were sounding. He cancelled them all, but did not tell the chief engineer or the bridge that there was a problem. He started the harbour service pump in an attempt to supply cooling water. Almost immediately, both port and starboard generators tripped. There was a total electrical blackout. This brought all the other engineering officers to the engine room. The emergency generator did not start because it was set to manual start. No one remembered this. So there was no lighting in the engine room and no electrical supply to the bridge. The chief engineer immediately stopped both main engines from the control room. He did not ask or even tell the bridge. The second and third engineers tried independently to sort out the problems in the engine room. There was no discussion about who was doing what and why. Chaos ensued. Although several alarms sounded on the bridge, there was no information from the engine room as the telephone system needed electrical power. The bridge team could only watch helplessly as the ship grounded, severely damaging both rudders and rudder stocks. Engine room watchkeeping requires a good understanding of the ship's machinery and systems, teamwork, keeping to company procedures, and good communications, particularly with the bridge. Both deck and engineering personnel need to bear in mind that they are all part of one team. This is important because the majority of ships are operating with day-working engineers and running UMS for much of the time. Engineers are still required to stand round-the-clock watches in certain situations. These include adverse weather, bad visibility, and when manoeuvring. But for most of the time, the responsibilities of the engineering watchkeeping officer, as set out in the STCW convention, are fulfilled by the duty engineer. And it is the task of the duty engineer that is the subject of this video. Good watchkeeping requires proper preparation, and this starts when a replacement officer arrives on the ship. A thorough handover is essential. Replacement officers need to learn about all the ship's equipment, especially the equipment that will be their special responsibility. Many companies have specific time requirements for handovers. but these times need to be seen as a minimum. The less experienced, the replacement officer, the longer the handover should take.
This is the manual auto switch, yeah?
Yes, when we want to synchronise two generators together, we switch to manual.
Replacement officers must find out about all the alarms, what they mean, and how to acknowledge them. All engineering officers must read the company's operations and safety manuals and sign that they have done so. The chief engineer's standing orders must also be read and understood and signed. The primary responsibility of the duty engineer is to ensure the safe and efficient operation of all machinery and equipment within the machinery spaces. The duties of the duty engineer start at different times of the day in different companies. Sometimes at midday, but often, as on this ship, first thing in the morning. The first task of the duty engineer is to make a complete round of the engine room before the morning meeting. The officer must inform the bridge of their entry to the engine room.
Bridge, this is 14 there.
The bridge will acknowledge. The next step is to activate the dead man's alarm. You must always do this when you're alone in the engine room. It's for your safety and is also mandatory under the SOLAS Convention. The round starts with a thorough check of the panels to verify that the electrical generating plant and distribution system is running properly. All the information available on the auxiliary engines must be checked. Remember that as soon as you enter the machinery space, you should use your eyes, ears and nose to identify anything unusual. Is there any sound, smell or visual clue that something is wrong? The usual practice is to start at the top of the engine room. Here, the boiler controls are checked. All the temperatures, pressures, fuel and oil levels are examined. Next to be checked is the economizer. Not forgetting to reset the dead man's alarm, the officer proceeds to the main engine. All the temperatures, pressures, fuel and oil levels need to be checked. During the first round of the day, the duty engineer needs to be certain that there are no leaks. The auxiliary engines need as much attention to detail as the main engine. Valves and flanges on pressurized fuel and lube oil pipes can work loose during unmanned operation. These leaks present a fire hazard, as well as the potential to cause trips and falls. Once the steering gear has been checked, it's time to go down to the lower level. The bilges need to be checked to ensure they are clean and there have been no overnight leaks. The round is timed so that it ends as the engineering team is gathering for the morning meeting.
How are you today? Yes, we have a lot of jobs to do today.
If anything is wrong, the duty engineer tells the second engineer so that things can be put right. If no immediate action is required, the second's plans can go ahead. The second engineer will explain what is planned for the day. One objective of the morning meeting is to ensure that everyone knows about everything that is happening in the engine room. If the second engineer has planned correctly, none of the jobs will interfere with each other. If anyone thinks that they might, they should speak up before the meeting breaks up. The deck department should be informed of any major work that could restrict their operations. One of the responsibilities of the duty engineer is responding quickly to all alarms. So it's good practice for the duty engineers to carry out crucial maintenance on their areas of responsibility on days when they are not duty engineer. Another important responsibility is responding promptly and accurately to bridge orders. The duty engineer should contact the bridge to find out about the specific operational requirements for the day. Communications with the bridge must be clear and concise. In key communications, always keep to proper procedures and repeat back the order, helping to establish what's called closed-loop communication. A further responsibility is completing the engine room logbook. Usually, the readings required for this are done around midday. These readings need to be accurate and reliable, so it's good practice when time permits and where possible to take the readings directly from the gauges on the equipment rather than the readouts in the control room. This provides an opportunity to observe the machinery and to check its condition. Duty engineers should ask themselves, has anything changed since I last saw the equipment? Is it noisy or very hot? Are there any leaks or unusual vibrations? The fuel oil service and settling tanks should be checked for water content. Once back in the control room, the remote and local readings should be compared. If there is a significant difference, this must be investigated. The duty engineer must be aware of all the work going on in the engine room and has a responsibility to ensure that correct procedures, appropriate checklists and lockout systems are being followed by everyone. The duty engineer needs good situational awareness. This means recognizing and responding to everything that is going on around you. This means using all your senses, sound, smell and touch, as well as sight, to identify potential problems during the rounds and whenever you are in the engine room. Careful monitoring of the fuel oil, lubricating oil, cooling water and air supplies to the main engine is essential. It means being aware of all tank levels, including fuel and lubricant levels, sludge and drain tank levels, as well as water and bilge levels. Every engine room has its problem equipment, and the duty engineer should check it regularly. Duty engineers should think about what could be done during their duty period to lower energy use. This includes reducing the number of auxiliary generators in operation and shutting down systems as soon as possible after use. Steam use should be carefully managed. Make sure that steam valves are closed on lines leading to tanks or equipment that doesn't need heating. It's worth noting that the responsibilities of the duty engineer continue even if the chief engineer is in the engine room. The duty engineer should use checklists when they are available. Each item must be actively checked before moving on to the next. Never just tick the boxes. Always ask yourself, how can I be sure that the equipment is really ready for use? It's good practice to go and check that the valves are set correctly and that the local and remote switchboards are set to auto-start. Officers who always rely entirely on the remote readings in the control room cannot have good situational awareness. The air conditioning in the control room is usually the best on the ship. It's there to keep all the electrical control equipment working properly. Unfortunately, it's not there to provide a comfortable rest area for engineering personnel. To have proper awareness of what's going on in the engine room, the duty engineer needs to get out of the control room and find out what's going on. That's the end of this section. Now, look at the workbook. The permit to work system is one of the foundations of safe working on board. Each company has its own system which must be kept to. In the system shown on this ship, only the chief engineer can sign permits to work. During the morning meeting, any work requiring a permit to work is discussed. If any hot work is required, or any work where there is a danger to life, such as entering any enclosed space or putting arms, legs or heads into machinery, then a special permit is required. If the work gets the go-ahead, then the officer in charge of the work inspects the site. All controls and valves that could be used to start the equipment are padlocked, so that they cannot be activated. In this case, the switch and the air line that supplies the required pressure to start the generator. The keys of these locks are then deposited in a special container on the control room bulkhead. This is then locked and the officer keeps the key. The equipment starting panel is tagged out. Before a permit to work can be issued, the site is given an independent check by another officer. As only the chief engineer can sign permits to work, he carries out the inspection. After inspecting the work site, he discusses the precautions that have been taken with the officer in charge of the work. When he's satisfied that all possible precautions have been taken to prevent injury, he signs the permit to work. This permit is placed above the locked compartment so that everyone can see what is to be done. A copy of the permit is put in a plastic wallet and placed at the worksite in plain view, again so that everyone can see what is going to be done. Then, and only then, can work begin on the equipment. At or before the time the permit to work expires, the procedure is reversed. Permit is signed off and the locks removed. Towards the end of the working day, the duty engineer should establish the progress of the work going on. What's been completed, what hasn't, and how it can be safely left overnight. At the end of the working day, the duty engineer must make a round before preparing to switch over to UMS. Every company will have its own checklist for switching to UMS, and this must be strictly followed. It's important that all personnel let the duty engineer know which jobs they've finished and when they're leaving the engine room. All permits to work must be checked to ensure that all equipment is secured and all personnel accounted for. If you want the chance of a good night's sleep, you need to check everything is operating properly. The officer must ensure that all fuel oil service and settling tanks are full, and the drain cocks are checked for water. Check that the cylinder oil tank is sufficiently full. Header tanks for cooling water and lubricating oil must also be checked. As per the company procedures, standby diesel generators need to be ready for auto start, as controlled by the power management system. All standby machinery must be in auto start and correctly lined up. The oily water separator overboard valve must be secured closed. Watertight doors and weather openings must all be closed. The alarms and fire detector system should be checked. Double check that everyone else has left the engine room. Finally, when the UMS checklist has been completed, inform the bridge before leaving the engine room. Most companies' procedures require one complete round of the engine room to be made during the UMS period. Always inform the bridge and activate the dead man alarm before entering the engine room. This round should be similar to the first round of the day. Starting at the top of the engine room, all functioning equipment needs to be checked. Always be thorough. Do everything you can to reduce the chance of an alarm sounding during the unmanned period. If any alarm goes off in the middle of the night, always come down the stairway. Never use the lift if one is fitted. You might be trapped in it. This will delay the response, and no one will know where to find the duty engineer. Even if ships are running UMS, there will be times when the engineers have to take watches. These depend on company procedures, but will generally include when the ship is in adverse weather, poor visibility, and when it is manoeuvring. There are some areas where shore administrations insist on a manned engine room. Watches are also required when any major backup equipment or control or communication system, such as the fire detection system, is not working properly. During these times, the importance of responding to bridge orders is always crucial. The control room must never be left unmanned. If it is possible to do rounds of the engine room, this should be done. The idea being to find and solve any problems before they are detected by the remote sensing equipment. The watchkeepers should make an effort to continue with routine maintenance during these periods. Any exceptional work will need to wait until the engineering department returns to day working. The primary responsibility of the duty engineer is the safe and efficient management of the main engine and ancillary equipment. To do this effectively requires a good knowledge of the engine room layout, its machinery, equipment, and pipeline systems. It requires a good awareness of what is going on in the machinery spaces at all times. It means responding promptly to bridge orders and following proper communication procedures. It also requires good communication with everyone working in the engine room. Always ensure everyone is wearing the right PPE, especially ear protection. Always keep to the company procedures when switching to UMS at the end of the day. Make sure you know under what circumstances you must call the chief engineer. Be cautious about the remote readings on the control room panels. Whenever possible, go out into the engine room to check the readings locally. Once out there, look around to see what's going on in the machinery spaces. Always use your sight, smell, hearing and touch to double-check the status of the machinery. The job of the duty engineer is one of the most important jobs on the ship. To refresh and improve your knowledge, watch this video again and consult the workbook.